So now we can calculate the z-score for the wheat data. So remind yourselves the z-score is y bar minus mu, where y bar is the sample mean, mu is the population mean, and in the denominator is sigma sub y bar, or the standard error. So now here's the z-distribution that I've drawn here. The peak of the z-distribution is when z equals 0, and in that case, that's when our population mean is 63. Now, what we observed in our sample was a sample mean of 74 bushels per acre. So we know that we're going to get a value of z that's greater than 0. So let's calculate it for our data. In our example, z is going to equal 74, our sample mean, minus 63, our population mean, divided by 47, our standard deviation, divided by the square root of 50. Remember, 50 was the number of samples that we collected. And remember, all this in the denominator here is sigma sub y bar, the same as sigma, the standard deviation, divided by the square root of n. It's the formula for the standard error. And so now we can look and we can calculate what z is. So z, when we calculate this out, is 1.65. And so if we go back to our curve, z is 1.65 when our sample mean is 74. And so that's kind of at the tail on the right side here of the distribution. So now we can look at the z-table and find when z is equal to 1.65. And so we can write this as the following. The probability that y is less than 74 equals 0.9505. And now remember, when you're looking at the z-table, it's telling you all the values to the left of some value that you specify. So it's telling us here almost the entire curve except for everything to the right of our sample mean of 74. So now that's nice to know, but what we really want to find out is, well, what's the probability when y is greater than 74? Well, to do that, we know that everything should add up to 1, and so we can just take 1 minus 0.9505. And what we end up getting is 0.0495. So what can we say? We can say something like there is a less than 5% chance of observing a yield this large. There's a less than 5% chance of observing a yield this large. So that would be pretty uncommon. So the mean is quite high relative to what we expect in the distribution. And so when we sampled, we found a sample mean of 74, but our population mean indicated that 63 was our population mean. And so that sample mean was actually quite large. So we can say, as we concluded, there is a less than 5% chance of observing a yield this large.